All right, so we're diving into a chapter on serving data from a data engineering book. And it's, oh man, it's a gold mine if you want to like really nail this presentation you're working on. Like we're going way past just how do you do it technically, right? It's like, how do we make data actually useful?
You know, what really grabs you in this chapter is how it keeps coming back to trust, right? Like, it's the bedrock of serving data well. If people who use the data don't trust it, game over.
Makes sense. It's not just about building pipelines covering data through them. It's about building trust with everyone who uses that data to like, make decisions.
Exactly. And the chapter goes into what happens if you lose that trust, right? Bad decisions get made, resources get wasted. Heck, your company could even take a reputational hit.
Yeah, no kidding. If your data's iffy, who's going to bet the farm on it? So then how do we as data engineers make sure that trust is there? Like, what do we actually do?
Well, there's a whole section on data quality. Like, that's the fuel for trust, right? You got to have serious data validation, observability baked in from the start.
Data observability. Now, that's something I'm hearing more about. It's like I've heard it compared to like having a health monitor on your data pipeline. What does that really mean?
It's like, imagine you've got this system, right? And it's always watching your data, like checking its pulse. So before anything weird hits your users, you get an alert. Data observability is all about being proactive, finding potential problems. So the data you serve is always, solid, accurate.
Okay, so there's that. Then there's SLOs, right? Being clear with users about how available the data is, how it performs.
Definitely. SLAs and SLOs, those are tools in your belt, right? They build trust because it's all transparent how you deliver the data service. But the chapter makes it clear that's not the whole story. It's got to be a whole company culture of like data quality, transparency. That's what matters.
All right, so trust, data quality, that's our foundation. What else should we be thinking about to serve data the right way?
Well, the chapter brings up this question: who are you serving this data to? And how are they going to use it? It's not enough to just, have the data. You got to understand the use case and the user.
So less about just providing data, more about really getting into our data consumers' heads, huh?
You got it. They even give you these questions to ask, like, how will they use this? What are the pain points? How do we actually work with them so the data meets their needs?
I'm sensing a theme here, collaboration, lots of it.
Yeah, for sure. And that takes us nicely into data products.
Now, data products, I'm curious about this. The chapter says they help you reach some end goal using data. What does that actually look like?
Think of it like a well-designed tool. It takes your raw data and turns it into something valuable, something the user can act on. Not just data for data's sake, it's data with a purpose.
So it's like packaging the data so it's easy to use, solves a specific problem.
You got it. And they lay out what makes a data product successful. Number one, teamwork. It's got to be a group effort. Stakeholders from all over, not just us data engineers off in our corner.
Right, bringing in different points of view, different expertise to make sure it really works for the business.
Yep. Another thing they highlight is these positive feedback loops. So a good data product, it's like it should generate more useful data as people use it. Gets more valuable over time.
So it's not just a thing that sits there. It's more like this system that learns, that improves as it goes. Interesting.
It is. And of course, got to be user-friendly, right? Too complex, too hard to use, people are going to ignore it.
Yeah, it makes sense. You want your data product to be the thing everyone wants to use, not the thing they avoid because it's a pain.
Exactly. Now, data products are all about making things easy to use, right? But then there's this idea of self-service data. Like, let's give users the tools and they can go wild. But the chapter, it says, self-service data starts with good intentions, but it fails.
Wow, that's a pretty bold statement. Why do they think self-service data is so hard to get right?
Their point is, it's not enough to just give people access to data and tools. Without a good plan, the right tools, and most importantly, continuous support and training, people get lost. They can't find the data, they don't get the context, they don't know the right analysis to do.
So it's about more than just giving them access. It's like giving them the knowledge, the guidance to use the data well.
Exactly. The chapter's big on this. You need a data-driven culture where, data literacy, being able to analyze stuff, that's valued. That's what makes self-service work, or any data initiative, really.
Okay, so we got trust, data quality, understanding the user, and the challenges of self-service. What else is in this treasure chest of a chapter?
Well, they dive into something that's often overlooked, but it's basic, right? Data definition.
Data definitions. Sounds simple enough, but I have a feeling there's more to it than meets the eye.
You're right on the money there. They're saying clear and consistent data definitions, that's what makes data correct, trustworthy. It's not just, oh, copy this data over here. It's about everyone knowing what the data means.
So it's about everyone in the company being on the same page about what the data actually represents.
Exactly. Like they use the word customer. Seems simple, right? But what is a customer? Someone who bought something once. Active users, what? If you don't define it, you're going to have people interpreting it all different ways, and that messes up your analysis.
Yeah, I see what you mean. One little word can have a bunch of different meanings, and that can lead to some bad decisions.
Exactly. The big takeaway. Those definitions, they got to be served implicitly, like built into the data itself. That's what makes everything consistent.
So it's not enough to just write the definitions down somewhere. You have to, like, weave them into the very core of your data system.
You got it. Which leads us to another cool idea that's becoming a thing, the data mesh.
Ah, the data mesh. I've heard whispers about this new way of organizing, managing data. What's the deal with that?
So the chapter describes it as this like decentralized network of data hubs. Each one's managed by a team that really knows that part of the data. It's different from the old way where one central data team tried to control everything.
So instead of one big data warehouse, you've got these, like, interconnected data neighborhoods, each with its own specialty.
Exactly. And in a data mesh, each team, they're not just managing their own data. They're responsible for serving it up to other teams.
So it's like data sharing, but directly between teams. Peer-to-peer data, kind of.
Exactly. It's got a lot of potential benefits. You're more agile, you can scale better, and teams really own their data.
But I imagine it's not all sunshine and roses, right? There must be some challenges to making this work.
Oh, yeah, for sure. To make a data mesh work, you need a good plan, good coordination. Teams got to agree on how they define data, systems have to talk to each other, and most importantly, a culture of collaboration.
Sounds like it takes a whole new way of thinking about data, how you manage it.
It does, but if you can pull it off, it can make your data way more agile, more valuable for the business. It's a trend worth keeping an eye on, that's for sure.
Okay, so we've talked about trust, data definitions, even this mind-bending data mesh idea. What other gems does this chapter have for us data engineers?
Well, from there, it goes into different types of analytics. You've got business analytics, operational analytics, and then embedded analytics. Let's break those down a bit.
Okay, I'm always up for connecting the dots between concepts and, like, real-world stuff.
Yeah, for sure. So let's say you're at a retail company, right? And you got to understand how customers buy stuff. Business analytics, that's where you analyze past sales, look for trends, figure out different types of customers based on their buying. Then you've got these insights that can drive, like, marketing strategies, pricing, even new products. That's business analytics in action.
So you're using the data to find those hidden patterns, the things that tell you how to make smart decisions for the business.
You got it. Now, switch gears to operational analytics. Think you're running a website. You got to monitor how it's doing in real time, right? Operational analytics lets you track things like how many people are visiting, are they bouncing off the site, what's converting. So if anything goes wrong, you can spot it and fix it right away.
So it's like having your finger in the pulse, but for your website. You can be proactive, react quickly to problems.
Exactly. And last but not least, there's embedded analytics. This is about putting those insights, those analytical goodies, right into the apps people use every day. Think dashboards in your CRM or performance metrics right there in your marketing platform. So anyone can use data, not just us data folks.
That makes a lot of sense. Embedded analytics can, like, empower everyone in the company to use data to make better decisions.
Absolutely. And that's really the whole point of serving data well, isn't it? Making sure the data is accessible, understandable, and, actually helps people do things.
Couldn't agree more. This chapter's given us so much to think about, and we're not even done yet.
We're just getting started. Next up, we're diving into the wild world of machine learning and how to serve data to those complex models.
All right, so we've got those data serving basics down. But now, machine learning, it's like the hot new thing, but can be kind of intimidating, even for us data engineers, right?
Yeah, I hear you. It's a whole huge field. But this chapter, it does a good job of boiling it down to what data engineers need to know to, like, serve data for machine learning, without getting lost in the algorithm weeds.
That's good to hear. So what are the key takeaways we should really focus on?
Okay, so first off, you got to get the different types of machine learning. Supervised, unsupervised, semi-supervised. Each one needs its own kind of data, and the way you serve it matters.
Right. I've heard those terms thrown around, but a quick refresher would be great.
Sure thing. So supervised learning, it's all about using data that's already labeled, right? To train a model to, like, predict things. You're giving it examples and telling it this is the right answer. Think of it like teaching a student with practice problems, showing them the solutions.
So you're kind of guiding the model, giving it a specific goal to aim for.
Exactly. Now, unsupervised learning, it's different. It's about finding patterns in the data, but without those labels. It's more about exploring, discovering, like giving a student a bunch of data with no instructions and saying, find something interesting in there.
So it's all about uncovering the hidden structures, the connections in the data.
Right on. And then there's semi-supervised, which is kind of in between. You got some labeled data, but not a ton. Like giving the student a few examples to get them started, then they got to figure out the rest themselves.
Okay, I'm seeing how Knowing these different approaches is key for us. Like, we got to know what kind of data those models need and how to serve it up right.
Exactly. And the chapter makes this point about time series data. You got to handle it carefully, especially for machine learning. This data, it's collected over time, right? So the order, the timing, it all matters.
Right, like stock prices, sensor readings, how many people are hitting your website, the when and the how much. It all makes a difference.
Precisely. Then there's the difference between like classical machine learning techniques and deep learning. We won't get into the techie stuff here, but the takeaway is different approaches work better for different problems.
So there's no one magic bullet. As data engineers, we got to be aware of all the different flavors of machine learning and understand their dietary needs, I guess you could say.
You got it. It's all about working with the data scientists, understanding their workflow. So they got the right data, the right format, right when they need it.
Collaboration, that's the word of the day, isn't it? Seems like it's fundamental to any data work, no matter what you're doing specifically.
You're telling me. Data engineering, it's a team sport, no question. Got to break down those silos, work with everyone. The data scientists, analysts, the business folks, make sure we're all pulling in the same direction.
Okay, so different types of machine learning, handling time series data. Let's get practical now. How do we actually serve the data? What tools and techniques do we have?
Well, this chapter gives you a real nice overview of the data serving landscape. It's like a buffet of options. Each one has its own pros and cons.
Love the food analogy. So what's on the menu?
Well, you got your classic file exchange, still pretty common for sharing data between teams, systems. It's simple, but not always the best for huge data sets or when the data changes a lot.
Right, like file exchange is kind of like mailing a package. It works, but it's not always the fastest or most reliable way to get something somewhere.
Exactly. Then you got your databases, the workhorses for lots of analytics and machine learning stuff. They're good at storing and querying structured data, So if you need to access data fast, they're your friend.
Databases are like the organized filing cabinets of the data world. Everything in its place, easy to find what you need.
You got it. But what about data that's always changing? Think data streaming in from sensors or social media. That's a whole other animal.
Right, that's where streaming systems come in, right? They can handle that constant flow of data, processing it as it comes in.
Bingo. Streaming systems are becoming super important because everyone wants those real-time insights to make decisions faster.
It's like having a live feed of data constantly updating so you always know what's happening right now.
Exactly. Now, what if you got to pull data from like a bunch of different places? That's when query federation comes in handy. You can query across different systems without actually moving the data. Saves you time and effort.
So instead of copying everything into one central spot, you can just go directly to the source and grab what you need. Efficient.
Right. And then you got these data sharing platforms, marketplaces, which are getting more popular, especially if you're sharing with like partners or customers. It's a secure way to exchange data so everyone can collaborate and do cool stuff.
It's like creating a whole data ecosystem where everyone can share and benefit from each other's data. Pretty cool.
It is. And then lastly, there's semantic and metric layers. They're like the organizers of the data world. They create this single source of truth for definitions and metrics so everyone's speaking the same language. No more confusion.
Sounds like a great way to pain the data chaos that can happen when you have data spread out everywhere.
Exactly. They're becoming more and more important as companies deal with data, exploding everywhere and getting stuck in silos.
Okay, that's a lot of options for serving data. How do we pick the right one for the job?
Well, it all depends on what you need to do, right? Think about how much data, how fast it's coming in, and what kind of data it is, security needs, and what your team can actually handle technically.
Right, the right tool for the job, just like you wouldn't use a hammer to screw in a light bulb.
You got it. And speaking of tools, let's talk about serving data to those notebooks that data scientists love.
Oh yeah, those books, those interactive environments where they can code, analyze, visualize, all in one place.
Exactly. There's a bunch of ways to serve data to notebooks, like using object storage, databases, data warehouses, or data lakes. You just got to make sure it's easy to access and in a format they can work with.
So it's all about making things smooth for the data scientists. Let them focus on their work without getting bogged down with data access headaches.
You got it. And that brings up a super important point that's often forgotten. Credentials.
Oh, right. Security. Can't forget about that.
Definitely not. The chapter's big on this. If you don't handle credentials correctly, in notebooks, data science code, you're asking for trouble. It's like leaving your keys under the doormat.
Yeah, not a good idea. We got to take this credential management stuff seriously if we want to keep our data safe.
No doubt. They recommend using credential managers or CLI tools. Don't ever, ever put your credentials directly in the code. Big no-no.
So set up a good system for managing credentials, keep everything secure and centralized?
Exactly, especially with notebooks where people are sharing code and data all the time.
Okay, we've talked about different kinds of machine learning, how to serve the data, even security. What else is in this chapter? We must be getting close to the end, right?
Well, there's one more thing worth mentioning, reverse ETL. It's a pretty new idea, but it's getting popular. It's all about like closing the loop between those data insights and what you do with them in the business.
Reverse ETL, huh? Sounds like we're going back in time with data.
It kind of is. So the chapter says reverse ETL is about sending data from your OLAP database, where you've analyzed it, back into your source systems, like your CRM or marketing tools.
So instead of just making reports and dashboards, we're sending the insights we've learned back to where they could be used to do stuff.
Exactly. Like, let's say you built a machine learning model to predict which customers are going to leave. Instead of just knowing who they are, you can use reverse ETL to send that info back to your CRM. And then, bam, you trigger personalized emails, discounts, whatever it takes to keep those customers happy.
That's pretty cool. It shows how reverse ETL can connect the dots between the data and what actually happens in the business.
For sure. And that's just one example. There's so many ways to use reverse ETL to make data actionable, to like personalize stuff in real time, automate tasks, and just make data a bigger part of how the business runs.
Reverse ETL sounds like a must-have tool for any data engineer who wants to make a real difference.
It is. It's not just about providing data anymore. It's about making things happen with the data.
I'm really digging this concept. Definitely something I want to explore more.
It's a whole new world out there. Reverse ETL is just getting started, but it could totally change how we use data to make decisions.
Okay, we've covered a ton of ground here. From trust and data quality to the ins and outs of machine learning, and now this reverse ETL thing. My brain is full.
I know, right? And we've only scratched the surface. There's always more to learn when it comes to data engineering.
That's for sure. But I feel like we've got a good grasp on the basics now, the important stuff for serving data well. What's next on this data adventure of ours?
Well, next time, we're going to take a look at the big picture, how data engineering is changing. We'll talk about some of the new trends that are like shaping the future of what we do.
Phew. We've gone deep on those core data serving ideas, tackled machine learning, even dipped our toes into reverse ETL. I feel like we've been through data boot camp.
Yeah, it's been a whirlwind, right? But we're not quite done yet. We still got to talk about how data engineering is changing, what the future looks like for all of us.
No, that's what I call job security. So what's shaking things up in the world of data engineering? What trends should we be paying attention to?
Well, the big one, the elephant in the room, is cloud-based data platforms. The cloud's changed everything, right? And data engineering's no different.
Yeah, the cloud is like the Swiss Army knife of tech. Scalability, flexibility, you don't have to spend a fortune on hardware. It's like having a whole data center in your pocket.
Exactly. And it changes how we think about data, how we manage it, how we analyze it. Remember we were talking about the data mesh earlier. That decentralized way of doing things, it fits perfectly with the cloud.
Yeah, it does seem like a match made in data heaven. So you're saying the cloud is pushing us towards a more distributed, collaborative way of doing data engineering.
You got it. And that's only going to accelerate as more companies go all in on the cloud and lean on data even harder for their decisions.
Okay, cloud's a biggie. What else is on your radar?
Another thing that's really picking up steam is real-time data processing. We're not just running batch jobs anymore, analyzing stuff after the fact. Now it's all about processing data as it comes in so you can get insights and react in real time.
That's got to be huge for things like catching fraud, spotting anomalies, even giving people those personalized recommendations everyone's talking about.
Exactly. And all this is possible because streaming tech's getting better and better, and there's just more real-time data sources out there.
So us data engineers, we need to be comfortable with both batch and streaming, know when to use which one.
You nailed it. Being adaptable, being ready to learn new stuff, that's crucial for any data engineer these days.
Okay, cloud, real-time data. Anything else we should be keeping an eye on?
Well, we can't talk about the future without talking about data governance and security. There's so much data out there now. Companies got to be super careful about protecting it, making sure they're using it ethically.
Yeah, data breaches are a nightmare. They can cost a company millions, not to mention trash their reputation.
No kidding. We data engineers were on the front lines of this. We got to help set up and enforce those security policies, work with the data governance folks to make sure everything's above board.
It sounds like data engineering is not just a tech job anymore. It's about security, compliance, even ethics.
You're right. It's all connected. Data's not just some technical detail. It's a valuable asset. Got to treat it with respect.
Okay, so cloud, real-time data, governance, security. That's a lot to chew on. Any parting wisdom on the future of data engineering?
I think it's a fantastic time to be in this field. It's changing so fast. There's always something new to learn, new problems to solve. Data is becoming more and more important for every business out there, so data engineers are in high demand.
Sounds like if you love data, love a good challenge, data engineering is a pretty sweet gig. Lots of opportunity.
Absolutely. It's a job where you can really make a difference. You're helping companies unlock the power of data, use it to do amazing things.
I love it. Well, this has been an incredible journey into the world of data serving. We've gone from the ground up all the way to what the future holds for us data engineers.
We talked about trust, data quality, understanding those users, and choosing the right tools for the job.
And we've seen how data engineering itself is evolving, becoming more collaborative, more cloud-based, all about getting insights in real time and putting them to work.
It's been a great conversation. I hope everyone listening feels ready to tackle their next data serving challenge head on.
Totally agree. And remember, folks, serving data is about more than just moving bits and bytes around. It's about making data useful, making it work for people, and making a real impact.
And never stop learning. Data's a fast-moving world, so stay curious, keep experimenting, and find new ways to make data sing.
Couldn't have said it better myself. Thanks for joining us on this deep dive into the world of data serving. Until next time, keep exploring, keep pushing the boundaries, and keep making data your superpower. 2025.